With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. So in this question there is a circuit which is shown and we need to find what is the reactance, impedance, the current and the reading of the ideal voltmeter, voltmeters. So there are several voltmeters which have been connected here. So basically this is our AC source 200 volt 50 hertz. This is the frequency and the inductance value is 2 by pi, resistance is 100 pi and the capacitance value is 100 pi, 100 divided by pi microfarad. Now this is V1, this is V2, this is V3 and V4 is basically across it is basically covering both inductor and the resistor, and V5 is covering all the three. That means this inductor, resistor and capacitor. So it is the potential difference V5 across all the things. Now we just for the first part we find what is the value of this reactance. Now first of all we say that omega would be equals to, because we will be having a value of omega is basically 2 pi f. Okay, so in this case the frequency value is angular frequency, this frequency value in hertz is 50. So we can say that omega value would be equals to 100 pi. Okay, this we should know. Now in the first part we need to find what is the value of the reactance. So XL value, we know that it is equals to omega into L. Now omega is what? It is 100 pi. And what is our this inductance value L? It is equals to 2 divided by pi. So it would turn out to be 200 ohm. Now in the B part we need to find what is the value of the impedance. Now to get the value of impedance, first of all we need to get the value of the capacitance, reactance. So capacitive reactance XC value, it would be equals to 1 divided by omega C. So we can say that 1 divided by omega is 100 pi into capacitance is 100 divided by pi and microfarad. So we need to multiply it by 10 raised to the power minus 6. So if we solve this, it would turn out to be 100 ohm. So we can say that Z value is equals to what? It is R square plus XL minus XC square in the square root. So we put all the values. So R value is 100, so it would be 100 square plus the difference of XL and XC. So 200 minus 100, it would be 100. So it would be square of 100 in the square root. So it would turn out to be 100 root 2 ohm. So we have calculated the value of the impedance. We need to find what is the value of the current. So the current value, we know that what is the AC source is basically 200 volt. We get the value of the total resistance of the circuit, or we can say that it is the impedance in this case. So the current value I would be equals to V divided by Z. What is the value of V? It is 200. So it would be 200 divided by 100 root 2. So it would be 2 divided by root 2, which would be equals to 2 by root 2 is what? It would be equals to root 2 ampere. Okay. Now in the D part, we need to find what are the potential difference across different voltmeter. So we can see that V1 is connected across inductor. So we can say that our and also we can see that these would be in series. So the current would be here, the same current would be going here, and the same current would be going here. Why? Because these are ideal voltmeters. So the resistance would be very high. So here no current would be flowing. So we can say that potential drop across inductor would be equals to I into XL. So V1, this would be equals to I into XL. I value is root 2 and XL value is 200. So it would be 200 root 2 volt. This is our V1. Now V2 is across the resistor. So it is very simple. So V2 would be equals to I into R. So I value is root 2. Resistance value is 100. So it would be 100 root 2 volts. Similarly, this is 100 root 2, not Z, it is root 2. Now we calculate our V3. V3 is across capacitor. So it would be I into XC. So I value is root 2 and XC value is 100. So again it would be 100 root 2V. Now in the V4. So V4 is basically across our this inductor plus. So this is our V4. It is basically across inductor and this we can say that resistor. So here it would be I and the impedance for the part of this impedance for our L and R part. So I is root 2. What would be the impedance for this L and R? It would be equals to R square plus XL square in the square root. So we put all the values. So root 2. So R is 100. So 100 square it would be 111000 plus XL. XL is 200. So if we square this, it would be 40000 in the square root. Okay. So it would be, if we just simplify it, so it would be 50 and then there would be 3 zeros. So we can say that it would be equals to 100, or we can say that 1000 under root 10 volts. Okay, so sorry, not 1000, but it would be 100, because these two zero would form one 10, and this 2 would be forming this another 10, so it would be 100, and then it would be root 5 that would be remaining, multiplied by 2 would be equals to 10. Now in the V5 we say that it is basically across the whole circuit, so it would be equals to I into Z. I is root 2, and what is the value of Z? It is 100 root 2, so it would turn out to be 200 volts. So these are the different values of the voltages. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.